All right, today's section is about using properties of midsegments and writing coordinate proofs. Oops, wrong button. How about that one? All right, so midsegment of a triangle. I'm going to show you with a picture instead of defining it. So if you have a triangle, a midsegment is formed by connecting to midpoints. So make sure you have that in your vocab definition. A midsegment is formed by connecting to midpoints on a triangle. So first thing I'm going to do is I'm going to eyeball my 3 midpoints, one for each side. Here's one, and if it's a midpoint, I need these segment marks. These are critical. Here's another midpoint. I need its segment marks. Another one, I need its congruent marks. Notice I did 1 mark, 2 marks, 3 marks, because I don't know if any of those sides are congruent. Now, how did I say a midsegment was formed? Connecting to midpoints. So I'm going to connect some midpoints. I'm going to connect these two, those two, and the last two. And you can see it makes kind of a neat little shape. It now has 4 smaller triangles inside that one large triangle. And the cool thing is those are all the same size. So it's pretty neat. The other thing that's really neat, you might want to write this down, if this piece is 12, this piece is half of it. Pretty neat. So the key thing, these pieces will be parallel to each other. So the red pieces will be parallel. I can kind of go around to a different side now. If I say this one is 14, find the one that's parallel to it, and that one will be half of it, which is 7. Last one, so I'll do in purple. So if this one, I'll say, if this one is 10, the one parallel to it is going to be how long? 5. Pretty simple concept. The other thing we got to talk about is coordinate proof. You've actually done these already. Coordinate proof is when you graph shapes and you prove things about them using a graph. What are some critical things you have to be able to prove when you graph things? Okay, sometimes you'll use slopes. What else? Side lengths. Good job. And slope deals with proving stuff about angles. Side length, how do you do that one? So count. You can do Pythagorean theorem. And distance. Distance formula. So remember, slope will let you find angles. These things will let you find side lengths. Those are critical on being able to prove things about shapes. In the past, we proved what types of triangles we have. We classified them by their side lengths. We said, are they right triangles or not? We're going to do some similar stuff with these. All right, so let's start off with this theorem. It's basically what I just said earlier. Find the sides that are parallel. And there's a special formula that deals with them. This little one is half of the big one. So DE is half of the length of the long one. You could reverse that around. You could also say what? AC is, how does it relate to the little one? It's twice the length of the little one. Yeah, DE. So you could say either of these and they would be valid. So we're going to apply it to this example down here. A large triangular window is segmented as shown in the diagram. DF and EF are midsegments of triangle ABC. Find DF and AB. This is a critical thing. It tells us they're midsegments. Find DF and AB. Remember, midsegments are formed by connecting what? Midpoints. So I connected these midpoints, these, and these. Now, I see 45 right here. It's parallel to what segment? AB, and you should see that pretty quickly. So if this is 45, we're going to double it to get the long one, because that's really just 45 plus 45, and that's how long? AB is 90. Just doubled it. Finding DF. Well, how do we find DF? DF is right here. It's parallel to what other piece? BC. Well, BC is 90. How do I find the small one? Take half of it. So half of 90 is 45. If we kept doing that kind of stuff, what do you think you could tell me right now? What kind of triangle do we have so far? Right now we know that this one is 90, and we know that this one is 90. We don't know this one because we don't have numbers on AC or DE. So what can we say about it right now? Isosceles is all you could say. You can't say equilateral because this side is unknown. So just isosceles right now. Definitely acute as well. In example 2, it says in the diagram at the right, QS is equal to SP. Let's mark that. QS is equal to SP. So I'm going to mark that. It's one of my givens. They also tell us PT is equal to TR. PT and TR. Show that QR is parallel to ST. I'll highlight those. Show that QR is parallel to ST. From what we have on the picture, you should be able to tell me that this is a midpoint because these segments are congruent, and this is a midpoint of PR because these segments are congruent. And anytime you connect two midpoints, you've just created a midsegment. So this midsegment, ST, will be parallel to the side running along QR. So that's critical. When you connect your midpoints, you're always going to have that. Example 3 says, place each figure in a coordinate plane in a way that is convenient for finding side lengths. Assign coordinates to each vertex. We're going to do a square and then an acute triangle. So it pretty much already gives you the answer. So we don't know the side length on either of those shapes, so we're going to use some variable names. The key thing that you should notice whenever you're placing a shape in a graph, in a coordinate plane, always make sure that your shape is placed with at least one side running along an axis. Whenever you have a shape like a square, you can put two sides running along your axes. This one, since it's not a right angle anywhere, you can only have one side running along the axis. Why do you think we do that? Say it again. It's easier. What's easier? It's easier to count. So automatically, on this square right here, I can count these two pieces. On this one, I can automatically count that piece. Square, I could do a little bit more because if you place it correctly, you can count all those because they're along the grid. But what if you had a graph like this and you placed your square like this? Could you count any of those? No, you would have to do Pythagorean theorem a bunch. So which one is easier? Obviously this one, where you're placing it conveniently. This one, the bad placement would be like this. If you place it like that, could you count any of those sides? Definitely not. So make sure to place at least one running along an axis. That's always smart. Also notice, if you go over S units, that'll be its new coordinates. If you go over S and up S, you're going to have S, comma S. 0, 0 is always at the origin. And then this is just up S units, so it's 0, comma S. That's something you should be familiar with. And obviously, if you got some numbers, you could change them out for numbers. Example 4 says, in example 3, part A, find the length and midpoint of the diagonal of the square. So here's our shape. It's graphed. We want to find the midpoint of a square. The good thing is, if I found this midpoint or the midpoint this way, it would come out to be the same because a property of squares say that the diagonals will be congruent. So we just pick one or the other. Since they told us to do that one, that's what we'll do. Let's try that real quick. Do y'all remember the midpoint formula? Midpoint is just the averages. So you add your x's, divide by 2. You add your y's, divide by 2. And make sure to keep the same order. If you do 2, then 1, then do 2, then 1. If you do 1, 2, do 1, 2. That's the midpoint formula. You definitely have to know that. That's from Algebra 1. Now in this case, they don't give us numbers, so all we can do is plug in the variables and the zeros. So I have to come over here and pick which one is my x1, y1, which one's my x2, y2. I would say leftmost would be my x1, y1. We'll say this is x2, y2, and sorry, it's hard to write small. Now I can plug them into my formula over here. So what goes in for x1? 0 plus my x2. What's my x2? S. And I'm going to divide by 2. What's my y1? 0. And my y2 is S. Some of this can be simplified. Anything plus 0 is just going to be itself. So I just get S. Anything plus 0 is just S. And that can't simplify anymore. So when you're dealing with variables, that's how you would get that one. If you wanted numbers, you could just quickly change those to 5s, and you could see it'd be 5 halves, over 2.5, up 2.5. I didn't pick these ones, they picked these ones, just to represent any case. That's why they chose a variable. That way you can plug in any number and make it work. Go ahead and try out these checkpoints. I'll give you a little bit of time to read these two. So this one, it wants you to sketch one on a graph real quick. So make a graph. Draw your obtuse scalene on that graph. And then number 4, find the length and midpoint of diagonal AC, which I've already talked about. Try those. So on these, we have to refer back, place an obtuse scalene triangle. So you have to know what's an obtuse scalene triangle look like. Here's how I kind of envision them. I envision them with a big angle and then a side. That's kind of how I envision it. There's a number of ways to place that triangle on a graph. The key tip that I want to tell you is always place one of the vertices on the origin. I would also try to always stay over here. Why do you think I want to stay over here? Because I only have positive numbers. So some of you that bled over to one of these other quadrants will have a harder time. But that triangle is pretty easy to take over here and place. I can just draw like that. That would be the best placement because all your vertices are positive and you have a vertice on the origin. You have a side running along an axis. I would definitely, if you don't have that, you need to change it. Number 4, find the length and midpoint of diagonal AC. So that picture in the past looked like this. They had a square, and they said this was S, comma S. This is S0, 0, 0, and 0S. It says find the length and midpoint of diagonal AC. I think, was AC this way? All right, so there it is. We're trying to find the midpoint. So I have to use these two coordinates in my midpoint formula. To do the midpoint, you need your midpoint formula. Once again, that's x plus x, divide by 2, y plus y, divide by 2. All we're doing is substituting these values in. So there's our x1, y1, and a lot of you didn't label, so you got a little stuck. If you don't label, there's no way you're going to be super successful unless you really know what you're doing. Next thing I need to do is I need to take these points that we just labeled and plug them into my formula. My x1 is 0, my x2 is 5, so that is 0 plus 5. I'm plugging directly, S. I'm plugging directly into my formula. And this should look very familiar. The other one is y1 plus y2. That's 5 plus 0. Sorry, s plus 0. I keep saying 5. 0 plus s is what? S divided by 2. And s plus 0, we already said that earlier. That's s divided by 2. There's the midpoint of AC. It also says find the length. We have two methods of finding length. We can use distance formula, which we wrote on the front page, or we could do Pythagorean theorem. I think distance formula or Pythagorean theorem would give you the same result. It would give you the same result. Let's try distance formula since we haven't done that in a while. So to use the distance formula, you have to know it. So it's square root of, y'all remember? Minus x1, square it, y2 minus y1. So I already have these labeled. That's a good thing. Once you label things correctly the first time, you don't have to do it again. So what's my x2? It's s minus our x1, 0, and square it. Our y2 is 0 minus s, square root over the top of all that. S minus 0 is just s, and then square that. 0 minus s is negative s, so I'm going to keep parentheses around that one because we got to deal with that. So s squared is just s squared. Negative s squared. What happens when you square a negative term? Yeah, negative times a negative is a positive, so that's another positive s squared. Now some people did some weird stuff. Here's one thing that I saw. I saw that, which is incorrect. Whenever you're adding, you do not mess with the exponents. So you can think of it as 1 car plus 1 car is 2 cars. And that's a simple way to do that one. It can simplify a little bit more also. Whenever you're dealing with multiplication, this is algebra 1. You can actually do this. You can separate them. And square root of s squared is just s. So I can pull the s out front. That's completely simplified. I was pretty happy though if you could get right there.